Hey guys, welcome back to my garage. In this video we'll be setting up the new Centroid KP-3 Kinematic Touch Probe. Okay, let's go over what comes with KP-3. You've got your cable, you've of course got KP-3, you've got the stylus and the stylus tightening wrench. You're going to need the KP-3 Touch Probe manual. You'll need a schematic, and you're going to need a small screwdriver and an Allen wrench set to complete the installation. You'll also want to install your KP-3 into a dedicated 1/2-inch tool holder. Once they're together, you'll want to leave them that way, and when you put your KP-3 away in its holder, put it away and keep it covered and keep it in a safe place. It's a delicate instrument, and once you've done all the alignment, you don't want to knock it out of alignment again. You might also consider putting a dot on your tool holder and a dot on your spindle so they line up, so it always goes in the same way. It's just a suggestion. But once you have this all put together, put it away in a safe place and keep it covered. You'll notice your touch probe came with a KP-3 flying lead cable. There are 3 wires, a white, a red, and a black. I've already gone ahead and crimped on ferrules on the end of the wire. I like to use the ferrules. You can buy these ferrule kits from Amazon. They're wire ferrules. Otherwise you can solder the tips of the wires. And then for convenience sake, you might want to consider putting on a connector so that you can plug and unplug the cable from your control cabinet. Basically anything that has 3 pins would be great. You'd want to put the socket side of the connector on your cabinet and then put the male pin side on the KP-3 Touch Probe cable. So with that, let's get it wired up to the acorn. Okay, according to the schematic, the black wire is going to go to common, the red is going to go to input 6, probe detect, and the white wire, probe signal, is going to go to input 7. Okay, my acorn is powered down, and you don't want to be wiring anything up to acorn while it's hot. So I'm going to take the black wire and I'm going to use the axis for COM terminal right here. And then our white wire is going to go to probe signal, input 7. And then our red wire is going to go to probe detect, input 6. Okay, so that's very simple, just 3 wires wired up that way. So let's go ahead and get started setting up CNC 12. Okay, let's go ahead and set up CNC 12 for KP-3 operation. So we'll start CNC 12. And the first thing I'm going to do is I'm going to click on Setup. So what you want to make sure is you have the latest version of CNC 12. You can see here I'm running the public beta release 449 Rev 4 dated May 12th of 2020. So you're going to want at least this revision or newer. KP-3 was designed to work and be set up with 449 Beta 4 or the latest release of CNC 12. So I'm going to go ahead and reset my bench test rig here. Set home just for the sake of doing it. Let's go ahead and go into the wizard. Okay, the first thing we're going to want to do, input definitions. We want to click on probe. We're going to want to drag probe detect to input 6. So we're going to left click hold, drag it to input 6, and then we're going to want probe tripped. Click on it, drag to input 7. Let's double check. Per the manual, probe detect is on input 6 and probe tripped is on input 7. Good. Okay, so the next part, we want to go over to probe and simply go up here to the probe type drop down, and we're going to select KP-3. And now we're going to write the settings to CNC control configuration. Write the settings to CNC configuration, yes. And it says PLC configuration is changed. The wizard and CNC 12 must be shut down and restarted for PLC changes to apply. Click OK. I'm going to go ahead and power cycle my Acorn board, restarting it. And I'm waiting for the heartbeat light. It's flashing rapidly right now. Now it's pulsing at about 1 pulse a second. Click OK. It should restart your CNC 12. All right, great. So we're back up. Reset. Click my home. All right, going to the manual, we go to KP-3 stylus installation. So let's go ahead and go over that now. Okay, to install the probe, you simply take the probe and you screw it into KP-3. Okay, I've got it finger tight now. Another thing you want to take a look at is make sure that the shank of the probe tip and the boss and the mounting boss of KP-3, there's no gap. Okay. The next thing you do is you take the tool, you insert it in the hole, and just give it a little snug. That's it. If you've got to take the stylus out, so you want to use a different stylus, a longer one, a shorter one, what have you, you take the tool, put it back in the hole of the stylus. I'll put my thumb under the probe and then my finger on the wrench and just pop it loose. So there it's loose. And again, to tighten it, I'm going to do the same thing. I'm going to go ahead and put the wrench in the stylus gently, put my finger behind the stylus and my thumb on the wrench, give it a little snug. That's it. Okay? So that's how to install it and remove it. Okay. Now we're on testing the KP-3. Bench test the KP-3. You can have the probe on the bench or in the spindle or whatever is safest. I happen to have mine on the bench. It says enter into the CNC 12 probing cycle menu. So we'll do F1 setup, F1 part, F5 probe, pick F1 bore probing cycle, and with the KP-3 plugged in, make sure the plug is fully seated. Again, make sure you get that plug all the way in. There's two detents. You want that plug face all the way up against the probe body. Manually trigger the probe by gently touching the stylus to trigger the probe and observe the probe state indicator graphic on the screen. If the probe is configured and wired properly, the probe tripped graphic on the screen will indicate that the probe has been tripped. So I'm going to go ahead and trip it. And there you see it's tripped. I'm going to release it. And it's back to normal. It's clear. I'm going to trip it again. It's tripped. So great. It looks like we've got it wired up correctly and it's functioning okay. Okay, what we're going to do now is we're going to manually test the probe in the machine. We're not going to probe apart, but we're going to use our finger just to trip the probe. Okay, at the top of this page it says, even after initial setup and operational verification, it is always good practice to get in the habit of manually checking the probe to confirm that it is functioning every time before running a probing cycle to prevent a probe crash. This quick test is easy and will save you heartache by verifying that the probe is plugged in and functioning before running an automatic probe cycle. So basically what we're doing is we're just going to manually test the probe before you run a probe cycle, especially if the probe's been out of the machine for a while. You want to just manually just check it to make sure that the machine is responding properly when you manually trip the probe. To manually test a touch probe using an automatic probing cycle, turn down the feed rate override to 10 or 20%. So let's turn down the feed rate to 20%. There we go. Position the touch probe in the center of the XY travel the machine tool. So my machine is currently set halfway in X, halfway in Y. With probe in clear space, start the center bore probing cycle. The probe will begin to move to seek out the edges of the bore at the quadrants. At this slow speed, you'll have plenty of time to trip the probe with your fingers to verify that it is working. No need to complete the probing cycle. Cancel at any time once the probe functionality has been verified. So what I'm going to do is I'm going to use the wireless MPG to start that probe cycle. So we're going to go into F1 setup, we're going to go to F1 part, F5 probe, F1 bore, and it says position probe inside hole. We're not going to put it down, we're going to leave the probe right where it's at, and we're going to press cycle to start. I'm going to use my wireless MPG, the cycle start button to do that, and then we'll go ahead and start the cycle. So I'm going to press start, watch the DROs. Okay, I'm going to gently trip that probe, and I hit it again, and it's working. So I'm going to go ahead and cancel the cycle. Alright, so we've successfully done that. The next step is touch probe alignment. Okay, here's the setup for checking touch probe concentricity. Install a KP-3 in a dedicated half-inch tool holder in the machine spindle, which we've got. Position the dial indicator as shown in the photo below. Here we go, we're all set up. Rotate the spindle by hand without touching the probe so that the probe spins through a full 360 degrees, and watch the indicator to locate the high and low runout positions of the stylus. Adjust the dial indicator so the entire runout of the tip can be seen on the dial. If the runout exceeds the range of the dial, then begin at the highest point of the runout. Set the indicator so it's at its limit of its range at this point. Okay, here we're set up for testing the runout on the probe. I've already dialed out most of the runout, but I wanted to show you guys. I'm hoping you can see the indicator. We do have some runout there. And you're going to use the wrench, and you're going to tighten or loosen very gently, very tiny increments, these 3 set screws until you get it in. And turning the set screw clockwise moves the screw in, but the body will come out. So if you tighten the screw in, the probe tip's going to come out at you. So just take your time, take small increments all the way around until you get it dialed in. I'm going to go ahead and see if I can adjust mine a little bit. Okay, there we go. I've got the runout taken care of on my my probe, so that takes care of taking care of the runout. The next step will be touch probe pre-travel, stylus diameter calibration procedure. Now we're set up for the stylus diameter calibration procedure. Here I have a ring gauge snug down to my table. I have my KP-3 up here. It says calibrate the probe stylus diameter for the tool library. Just entering these values of the probe tip diameter in the tool library will not produce accurate results unless they are corrected for stylus pre-travel. Pre-travel is the amount of deflection of the stylus tip before the probe detects the surface. This value varies depending on the length of the stylus and the speed and direction that the stylus tip is moving when it makes contact with the surface being probed or digitized. Pre-travel variation amount should be stated in probe specifications relative to stylus length and direction of travel limitations. A probe that has a small pre-travel variation with no restriction on stylus length and direction of travel will be quite extensive. Machine characteristics, including lash and input latency, also contribute to the need to calibrate the stylus diameter. In order to achieve optimal results when probing or digitizing, each stylus tip size must be calibrated to compensate for the sum of the effects previously mentioned. The following procedure is the quickest way to determine the calibrated diameter. So basically, every time you change this tip, you need to run this pre-travel calibration procedure for each tip. So if you have no reason to change it, then leave it and you don't have to worry about it. But if you're changing the tips, you've got to rerun the pre-travel stylus calibration procedure. Stylus diameter calibration procedure. Fixture a precision ring gauge on the machine tool, which we've got. Ring must lie flat on the work table vise with the center line of the bore to be aligned with the center line of the probe stylus spindle. make sure that the probe is plugged in and working. So we need to make sure the probe is plugged in and working. So this bears mentioning. Make sure that this plug is all the way in. Ask me how I know that. So make sure that the plug is all the way in. It has a couple of stops. It has the propensity that it can go in part way but not all the way. Okay? So make sure this is fully seated. And then we want to double check it. I'm going to run the probe routine. F1 part, F5 probe, F1 bore, and then I'm just going to use my my start button here. Okay, so it's working. So always do that before you run your probing routine. Make sure your probe is working. You can also double check, make sure that the LED is working. If the plug is not in all the way, you won't get the LED to light. So make sure that plug is in all the way. Check it, and since I took it out, I'm going to run the test again. Cycle start. Okay, it's working. Fix your precision ring gauge on the machine tool. The ring must lie flat. Make sure the probe is plugged in and working. We just did that. Go to the tool library offset menu and set the diameter for the probe tip to 000 in our case for tool 10. Is it a probe tool number? So we set diameter 10 to 000. We're going to go F1 setup, F tool, and then we'll go to offset library, and it's 0 and our diameter is 0 right now. Okay? So that's done. Okay, the next step. Jog the probe over the center, roughly, of the ring gauge and slowly jog the Z-axis down until the tip of the probe is inside the bore, not touching anything. So I'm going to bring it down. Okay, we're roughly centered in the ring gauge. It says from the main screen of CNC 12, press F1 setup, F1 part, F5 probing, and then F1 bore. And then we're going to press cycle start. I'm going to use the wireless MPG to do that, so let's go ahead and do that. The control will jog the stylus and probe each quadrant of the bore. It will then return to the center of the bore. Message box will appear on the screen displaying the measured bore diameter. Subtract this number from the known diameter of the gauge bore. So in my case, it's 0.985 is my ring gauge. Subtract 0.8297 equals 1.553. The resulting number will be the calibrated diameter of the probe stylus tip with the pre-travel taken into consideration. Test number 4 is test the new probe diameter. Go back to the tool library. Let's go to the tool library. We're going to go F1, F2, and then F1 offset library. I'll go to diameter here. We're in 10. And enter, in our case, 0.1553. Enter. And then we'll save that. F10 save. Okay? You can tweak the probe stylus pre-travel calibration diameter and repeat as needed to obtain as close a measurement as possible to the actual ring gauge diameter. Assuming the machine has low backlash and the probe is accurate, it is possible to obtain plus or minus 0.2 repeatability when measuring the ring gauge diameter with good probe and machine in good condition. The probe stylus calibration is now complete. Probe is ready for probing and digitizing. Each different stylus will have a different pre-travel compensated calibration diameter. Do this procedure for each stylus. Make a table and record the calibrated diameter values for each stylus. Be sure to update the probe diameter in the tool library to match the stylus being used when swapping out to a new stylus! Okay, so let's go ahead and test to see where we're at. Let's see if we're fairly accurate. So we're going to go F1 setup, F1 part, F5 probe, bore, and then let's do the cycle start. .985. That's exactly what our ring gauge is. Still one more time. .985. Congratulations, the probe is set up. Okay guys, I hope you enjoyed this video. I hope it helps you set up your KP-3, gives you a visual explanation when you're using the KP-3 setup manual in conjunction with this video. Many of you may have noticed I used my Fadal to set this up. CNC12 servo and CNC12 acorn are very similar, so the setup procedures are very much similarly the same. I use the Fadal because it's easier to do this video on. So anyway, until next time, be safe and enjoy your new probe.